Hi all, in this video I am going to explain how the increase of gain affects the transient response. That is explained with the root locus plot. Okay, consider the open loop transfer function g of s is equal to k by s into s plus 2, that is given. What is numerator polynomial? N of s is equal to k, and denominator polynomial d of s is equal to s into s plus 2. To draw the root locus plot, first of all, we should find out the poles of the equation. How to find the poles? That is step number 1. Denominator polynomial d of s is equal to 0. We get the poles s is equal to 0 and s is equal to minus 2. Now I am going to mark the poles. The cross mark which is used to mark the poles of the characteristic equation. And next I am going to examine how the increase of k is the gain, changes the value of the pole. To examine this, first of all I am going to find out the characteristic equation. So what is the characteristic equation? 1 plus g of s into h of s equal to 0. Here h of s is the unity feedback. H of s is equal to 1. So I have to apply the value 1 plus k divided by s into s plus 2 equal to 0. Next I am going to cross multiply this. S into s plus 2 plus k equal to 0. Have to expand this. S square plus 2s plus k equal to 0. Now I have to plot a tablet column. Put k here, then p1 and p2. Put k is equal to 0. When k is equal to 0, s square plus 2s equal to 0. So what are the values? S is equal to 0, s is equal to minus 2. These two are the poles. Next, put k is equal to 1. S square plus 2s plus 1 equal to 0. We can rewrite as s plus 1 the whole square equal to 0. So s is equal to minus 1 and minus 1. Next, put k is equal to 2. S square plus 2s, instead of k have to put 2, 2 is equal to 0. How to find out the roots of the characteristic equation? Minus 2 plus or minus square root of b square 4 minus 4ac 4 into 2 into 1 8 divided by 2. That is minus 2 plus or minus square root of minus 4 divided by 2. Minus 2 plus or minus j2 divided by 2. The answer is minus 1 plus or minus j1. When k is equal to 2, I get the answer minus 1 plus j. Here minus 1 minus j. Then put 3. We get the answer minus 1 plus root 2, j root 2, minus 1 minus j root 2. What is the value of root 2? That is 1.414. Then put k is equal to 4, I will get the answer minus 1 plus j root 3 minus 1 minus j root 3. If we increase the value k up to infinity, the value also increases. P1 and P2, both the poles are increases. Now I have to mark the pole. When k is equal to, here this is k is equal to 0 and this is also k is equal to 0. When k is equal to 1, this is k is equal to 1 minus 1. And if we increase the value further, when k is equal to 2, I will get the answer minus 1 plus j and minus 1 minus j. Okay, here j, here root 2 j, root 3 j, minus j, minus root 2 j, minus root 3 j. So if we increase it further, the gain is 2, gain is 3, gain is 4 up to infinity. Here gain is minus 2, Here, sorry, gain is 2 only, not minus 2. K is 3, K is 4. Okay, so this is symmetrical about the real axis. If we increase the K further, but the value also increase. Now this is in a imaginary plane. An imaginary value is obtained. So from this tablet column, we can tell that K is less than 1. The roots are P1 and P2 are real and unequal. So we can say that this is a overdamped system. And K is equal to 1. Multiple poles are obtained. So we can say that this is a critically damped system. And if we increase the K further, we get the underdamped system. So this system is underdamped system. These are about the characteristics of the roots for different systems. Now we look at the underdamped system of the root locus. Real part of the complex is same, complex portion. Real part is minus 1. There is no change in the real part. Here also there is no change in the real part. It is always same. But the complex value, imaginary value only changed. There is no change in the real part. Okay. So this is corresponding to the settling time of the second order system. How to write this underdamped portion? Minus zeta omega n plus or minus omega d. What is settling time? Settling time is inverse, that is 4 by zeta omega n. Okay, zeta omega n, there is no change in zeta omega n, but omega d, j omega d portion only change. So settling time is proportional to the real part of the complex whole for the second order system. So regardless of the value of gain, settling time is always constant. So settling time does not change with respect to the gain, but only one, the imaginary part only change with respect to the gain. Okay, thank you. Have a nice day.